Hello folks, let's come back with this problem 7 of this exercise 7.5. It's a slightly different problem because if you can carefully observe, we have a numerator which is a linear, and in the denominator you have two factors. One is a quadratic and the other one is a linear. Not only that it's a quadratic, but it's a quadratic irreducible. Any expression which is of the type x squared plus a, where a is a positive integer, will always be irreducible in real numbers. So here this x squared plus 1 is irreducible. So whenever you have such irreducible quadratics in the denominator, then there is a different kind of substitution that has to be applied. So we'll be applying that substitution and we'll be doing the problem after having applied that. I'll let you know, as I told you, having it done right in the beginning, it would be a little confusing. So as the case comes, we will be, so right now we have seen expression with two linears in the denominator and three linears in the denominator. Now this is a separate variety where we have a quadratic irreducible along with a linear in the denominator. So whenever you have such things, we are going to make a substitution like this: x over x square plus 1 times x minus 1 whenever you get. For this, we will write it as ax plus b. Whenever you have a quadratic irreducible, we will use this linear above that quadratic, and then this, since it's a linear, so we write c over x minus 1. Now it's our task to have the denominators equalize, so this entire fraction will be multiplied by x minus 1, this entire fraction will be multiplied by x squared plus 1. So it is like ax plus b is multiplied by x minus 1, and this is multiplied by x squared plus 1. You have the denominator, overall denominator as x squared plus 1 times x minus 1, which gets equalized with the ones here. Since the denominators are the same, they get cancel each other, and so this is your expression. It's for us to find the ABC value, so we make substitutions. So first let the substitution x be 1. So if x is 1, you have the expression a. Of course, if x is 1, this entire term vanishes, so you don't have a term here. And let's see this c. So x is 1. So 1 square, which is 1, 1 plus 1, 2. And this is also 1. Like that, you get the c value as half. Now let's move to the next, where this x squared plus 1 doesn't give us such a ready substitution. So let's call x as 0 for that. So if x is 0, then in that case, you will get a times 0, that vanishes, so only b is left, and 0, so that's negative 1, and then c is there, which is half, and x squared, so that's 0 plus 1, that's 1, and then you have 0 on the other side. We have made all kinds of substitutions, so therefore you are getting this is minus b, which can go on the other side, so b can become half. The value of b that we get is half over here. Now after that is over, let's move for getting the a value, and that also we don't have much, so let's call x as negative 1. Check over here what will happen. If x is negative 1, then a we don't have, so it's a times negative 1. B we have half, and then let's have so b we have half, and then times negative 1 is negative 2, so that's done. And then here we have plus c, which is half for us, half times x squared plus 1. X squared means it is 0 squared, sorry, it's minus 1 squared, which is 1, 1 plus 1, so it's 2. And on the other side, we have x, which is minus 1. These are the substitutions. Now let's see how it works. Minus a plus half times negative 2. And then here it is 1. This is simplifying to 1. Let it go on the other side. So that will become minus 1. So you have negative 2. Minus a plus half times negative 2. These two negative 2's, they can cancel, or rather you can divide both sides. So you will be left with minus a plus half, because it has cancelled, 1 is there. Now maybe let the a go there and let the 1 come here. So when a goes there, it becomes positive. Let the 1 come here, half minus 1. So a becomes negative half, whatever be. So we've got all the three We've got c as half, we've got b as half, and we've got a as negative half. Let's go back to I. I is not going to be simple because there's a linear in the numerator. So it's not going to be as simple as before. So this is the expression which is going to help us. So let's see now how it is. The first part, it is going to be ax plus b. So that is negative half x plus b, which is half, over x squared plus 1 dx. That's first part. Second part is c. That's okay. Second part is okay. It is half. So that is half over x minus 1 dx. Now this half, let's remove. So if you can remove the half out, then we are getting negative x plus 1, and denominator is x squared plus 1 dx. And here it is here also the half you can remove out, but that's easy because it's a linear in the denominator, so finding the derivative is easy. But here finding the derivative is not easy. Why? Because the derivative, the denominator is a quadratic, but the numerator is a linear, and the numerator is not even the derivative of the denominator. If the numerator is the derivative of the denominator, still you can find out easily the integral, but here it's not the case. So therefore you have to express the numerator as derivative times denominator and all that. So here, let's see, here consider negative x plus 1, negative x plus 1. Now this negative x plus 1 you express as d times, because we have already used till c, so I'm calling it as d times. Let's take the derivative of the denominator. Derivative of the denominator is 2x plus e. So if that is the case, it's when we correspond it, we'll come to know that 2d is negative 1 and e is 1, isn't it? When we correspond, 2d is negative 1 and e is 1. So d is negative half. So let's reframe I once again. I, instead of writing minus x plus 1, let's write it in this term. That is minus half times 2x plus 1. And then let's separate it. X squared plus 1 dx. Half is there. And yeah, this is x squared plus 1 dx. And then there is that half times. Don't forget the half here also, because the half is common to both. Dx over x minus 1. We have to be very careful because we have split this as d times 2x plus e. D for us is negative half. So negative half times 2x plus e, which is 1, but then there is this half which is common, so everything has to be accounted for. Now let this negative 1 over 4, let it come out. So it's like negative 1 over 4. So it's positive 1 over 4 because both are negative. So it's 1 over 4 that's coming out. And then, or is it, it's just half. So, oh, sorry. Yeah, it has to be negative. Yeah, it has to be negative because we've taken the negative out. So you are having now 2x over x squared plus 1. That's good because the numerator is the derivative of the denominator. So that makes the work easy. And now this is half times integral of dx over x squared plus 1, and then half times integral of dx over, all are very easily integrable function, negative 1 over 4. Whenever you have the numerator as a derivative of the denominator, then your integral is always log of the denominator. Now, if you don't get convinced about it, you can call u as x squared plus 1 and proceed. You'll be able to get it. So, therefore, this is log modulus x squared plus 1. For the second one, it is half times x squared plus a squared, integral of dx over x squared plus a squared. We have learnt it last time in special functions. It is 1 over a tan inverse of x over a. So 1 over a is 1 here, so doesn't contribute, tan inverse of x, a is 1. So it will be just tan inverse of x plus the next one, it is log modulus x minus 1 plus c. So many things to account for. So we're getting negative 1 over 4 . That's it, log modulus x minus 1. So that's about this, where we have done it for the first time. When we have a quadratic irreducible in the denominator, we are careful to substitute ax plus b in the numerator and then proceed. So we do have problems like that coming up again in this exercise. So that time we'll be careful for this new substitution. So that should be all for this video. With more problems, let's meet in the next video. Thank you.